Hello and good morning and welcome to this webinar. My name is Neil Cook and I am the Technical Services Director here at Onshape. Today gives me great pleasure to introduce Stefanos from Phenometry. He's a co-founder there and he's going to be talking about products called Phi, as well as introducing some of his customers to show how Phi is being used to create freeform services inside Onshape. Before we start, we'd like to just make sure that everybody is aware that you can ask questions. So in the GoToWebinar question panel, you can enter your questions and we'll try our best to answer them at the end. So we'll leave about 10 minutes or so for Q&A. And those can be questions about Onshape, or they can be questions about Phi, whichever, it really doesn't matter. Okay, so but please enter those questions in as you think of them, so we're not bombarded right at the end. Before we jump into freeform surfacing with Phi, I'd just like to spend somewhere between 5 to 10 minutes just to talk about Onshape for those of you who may not be familiar with Onshape and what it's all about, and particularly how we do surfacing inside Onshape as well. So first of all, what is Onshape? Okay, so Onshape is a product development platform, a CAD system for want of a better word, but it's also in the market today. There is a lot, CAD has been around for 30 plus years. That's 3D parametric CAD. But currently, Onshape is the fastest growing CAD system in the market as recognized by engineering.com. And we expect this to be the same for many years to come. And even though this is a very saturated market, we are growing at 10 times the market rate and already have over 2 million users. Okay, so why are companies switching to Onshape? And it's really not so much that our CAD is better and faster, which of course it is, but really about what are the problems that people are facing with running a 3D CAD system on-premise, desktop installed, PDM on a server, in-house CAD system. What are the issues? Okay, and some of the problems really with file-based CAD relate to things like high total cost of ownership. I mean, companies are spending significant time and money on really what are considered the hidden costs of deploying on-premise CAD software. The initial purchase price is not what you're paying, because that's the price of the software. But you then also have things like expensive software and workstations, software upgrades, annual maintenance costs, servers for PDM, IT staff to manage it and back it up, and so on. There's a lot of hidden costs related to that. Also, when it comes to actually finding data, okay, and we recently ran a survey, the state of product development and hardware design for 2021, and 80% of those respondents complained that it was difficult to either access or locate the design data that they need. I mean, they get it there eventually, but in a timely fashion. It was taking a long time for those engineers to find the data they need. Now, PDM fixes this issue, but it does again lead to a higher total cost of ownership and slows down the design processes, which brings me onto the next topic, which is, again, in the same survey, many respondents, or 1 out of 2, were complaining that having a PDM system or even a PLM system actually slows down the overall design process, simply because there's an issue with accessing the data, checking it out, downloading gigabytes of data over a network locally to their machine, to fire it up in the CAD software, to do the design changes, to save it locally, to upload it back to the server, to check it back in. The whole process is very, very time consuming. Okay, so it slows the whole process down. And when that data is checked out, of course, that data is locked and nobody else can access it. So if you imagine somebody opens a top level assembly, somebody wants to insert their sub-assembly into that top level assembly, they can't, because somebody else has that open and locked. Okay, so that's the issues with PDM, and the 2 out of 5 is basically when the data is locked, so people can't access it. Okay, poor collaboration, and this is really about having siloed data between departments. So the engineering department work in their CAD system, they have their local PDM system, they can access their data, maybe not in a timely fashion, but they can access their data when they need it. But then if they need to collaborate with others in the design process, so that could be reviewers, approvers, the manufacturing, suppliers, customers, getting data from one person to another usually ends up with things like email or FTP. And that makes numerous copies of files on lots of different people's desktops. And then you get to the issue where, which is the latest file? Who has the latest file? Are we manufacturing the correct version of this product? Who knows, because there are so many copies of files around the place, both internally and externally. And also because working on a file-based CAD system, that does pose a security risk. We've all heard those horror stories where Department of Defense people have left laptops on trains with very sensitive files on them, and thumb drives left hanging around. But that's just what you read in the news. A lot of the things that you don't realize, of course, is that when you email data, as soon as it's left your email server, it's out in the wild. You don't know who's got it. You don't know what they're doing with it. You don't know if they're sharing it with other people, whatever the reason. Because you are moving your sensitive data around in a file, then there's a lot of issues with that. And finally, just having desktop installed software. CAD software is very complex. It's if you compare it to something like a word processor or a spreadsheet, which also do crash, CAD software is incredibly complex, and so it crashes very easily. Because it's all on the desktop, crashes, it takes it down, you lose the CAD data that you're working on, you've got to reproduce it. If you didn't save recently, or perhaps you save and it corrupts the files. There are so many issues related about this. And these are just some of the kind of high-level topics or high-level issues that people have with working on-premise file-based CAD systems. Okay, so what's the solution? The solution is to get rid of files from the equation totally and move everything to the cloud. And this is basically what's Onshape. It says cloud native, meaning that it was written to run on the cloud. It's not just some software which has been placed on a cloud storage device. Everything, the data is stored in the cloud, the CAD system and the data management is all stored in the cloud, and it all works together seamlessly. And it gives you things like advanced collaboration, so you can have multiple users work on the same document at the same time. I'm just going to show a quick demo of that in a moment. On-demand analytics to basically work out where bottlenecks are in the process and optimize the development process. Easy to use interface, access from anywhere, from any device. As long as you've got an internet connection, you can use your phone, your tablet, your Chromebook, anywhere to get access to that data. So you're never without the data that you need. There's enterprise-grade security using Amazon Web Services, and of course our own security on top of that. There are 0 crashes. That's right, you heard me right. Onshape does not crash, simply because of the architecture of the cloud. We use a lot of the same components that a lot of other CAD systems use, but because of the architecture of the cloud, we can queue up servers. So if something happens to one, another one takes over. The end user, yourselves, don't see any issue at all. So the end user experience is that there are 0 crashes in Onshape. And we do updates every 3 weeks. There's never any downtime. There's never any server maintenance. We're not taking it down for the weekend and asking you to install anything locally. Everything's accessed through a browser, updates automatically. You literally sign in one day and then sign in the next day, and it will say Onshape's updated. Click here to see what's new. Okay, having said that, let's have a quick look at Onshape itself, and really just to focus on the surfacing, but also how collaboration works. So we see in this model here of a bottle, it's just a surface model, but I'm accessing this directly through a browser. So I've not had to download or install anything. I've just connected a computer, access the internet through a browser. So you can literally get a brand new PC and be up and running within seconds of getting to, so there's no setup required at all. Okay. Onshape is a 3D solid parametric feature-based solid model. Okay, it's using the same technology that PTC invented back in the 80s with Pro Engineer, and of course then the other products copied suit. Things like SolidWorks and Solid Edge and Inventor all use this concept of parametric feature-based solid modeling. So what that means is, if I was to look at this surface here, for example, we can see that this surface, while it looks like a very nice, very smooth surface, is actually created from multiple sections going in one direction and multiple curves going in another direction to get this surface in here. And it means that if you look at the curvature, it does look like a real nice surface. So you can do a lot of really intricate surfacing within Onshape. The issue you really got is with the process of creating parametric feature base is that it is very there's a lot of detail that needs to be put in there in order to create those services, as well as you kind of have to plan ahead. There's a little bit of trial and error involved because you're tweaking the quality of your curves to get the quality of your surfaces, and if you've not quite got it right, then it might not produce the surface that you need. So then you have to go backwards and forwards. So if you're creating something which I like to call this technical surfacing, because if you need to create surfaces in order to produce a product or in order to create solid model, then Onshape will do that, absolutely no problem. Simple products like this bottle, no problem. If you want to do something a little bit more freeform, then that is where Fi will come in, and we'll take a look at that in a moment. But really, one of the reasons why people choose Onshape over any other system is really around collaboration. So if I've designed this model here and I want to share that with somebody, I don't need to go through the process of creating the file, exporting it, emailing it, any of that business. I can basically just say, okay, this person's email address, specify whether they can view or edit, and then just share that data. Okay, that is literally all you have to do. So if you've ever used Google Docs, it works in the very same way, that you just put in somebody's email address, they get pinged through an email, and then they can get access to the data that you shared with them. And what does that mean? So this person on the right here, they click the link on the email. If they've never used Onshape before, then I'll ask them for a password, create a password, and from that point forward, they can then get access to the data that you've shared with them. Okay, so this is the very same model. Okay, not to download and install anything, just click the link on the email, just opened Onshape in my browser. Not to pay for anything, so it's basically a free viewer in here. But there's lots of things you can do, take section views, look at properties, and so on. If it was an assembly, look at bill of materials, look at drawings. You can give people export permissions, so if they need to create an STL file of it or print a drawing, you can do that as well. But typically, most people use this for giving feedback. So, for example, if I sent this design to a customer and they were reviewing it, and they might want to do something like this. So they might want to first of all tag me, okay, and assign that as a task to me. They might want to tag some geometry on the screen, or they might literally just want to do something very simple, like drawing here. So very easily we can do this, and perhaps put a note on here and say, can we have a constant, I don't remember what it's called then, constant width fillet. Okay, so this is so bear in mind that I've not actually done anything here, not installed any software, not installed any viewers or anything, but quite literally from a web browser, I've then just gone ahead and assign that. And then if, as the designer, if I'm in the document at the same time, then that's going to appear here. And of course, I can get access to that data there. So very powerful way to collaborate between both internal people and external people. And you can do things like this where you've got where you can do follow mode. So when somebody's in your document, you can see exactly what they're looking at on their screen. So you don't have to create a like a screen share session. When they select something, you can just talk to them on the phone. They say, "Can you please change this fillet?" Okay, let's do that. So whether I'm changing the fillet here or whether I'm giving them edit permissions, then if I was to just change this, let's make that constant width fillet. What you'll see is as soon as I press OK on here, is that it will update in real time. Obviously, once it's generated the fillets, but in real time on the other person's screen. So again, you're not having to go around and modify or create new files and send those files again. Everything is seamless, and this is really one of the benefits and the main benefits of working in the cloud. The data stays in one place in the cloud. Everybody can access it from any location. We don't need to worry about installing software or software crashes or having a PDM system because it's all built in. Okay, that's my little my pitch over about Onshape. I've talked about surfacing. Let's take a look at now how it's dealt with in Fi. So right now I'd like to introduce Stefanos from Phenometry, who's then going to talk to us about freeform surfacing.
Hello. Neil, thank you very much for the introduction, and hello to everyone. I hope you can see my screen right now. Um, is, um, is my screen visible already?
Yes, we see it.
Perfect. Okay, so I will take a few minutes to quickly present Phi and give some examples of what it can do and how it can be used. So Phi is, as Neil introduced, a freeform surface modeler that is an add-on to Onshape. You can find it in the Onshape App Store. And it's basically a new kind of design tool. It's not based on the typical technologies that you encounter in the CAD world, like NURBS or T-splines or subdivision surfaces. And the general idea is that you focus mostly on your edges, on your curves, which drive your design intent. You manipulate these, and Phi automatically and interactively calculates nice, smooth, where required surfaces for you. So you have this free kind of design experience with no restrictions, such as having to work with control cages or control points or specific types of surface dimensions and things like that, while at the same time having nice watertight smooth surfaces. And as I mentioned, Phi is available at the Onshape App Store. You can try it out for free. And it's also completely free for educational users, educators, and students as well. These are just some examples of things you can design with Phi quite easily. And before I go into some demo, I'd like to mention that Phi is a constantly evolving product. So we release about 2 or 3 new versions every month with new features, new capabilities, and improvements. And these are largely driven by our users who give us feedback about their needs and things that they would like to see slightly different. And in fact, within the application itself, we have a little icon that if you click on, you can add your own suggestion and help us improve Phi and make it even better for you. Now, being a new type of design tool, of course, it comes with some new functionalities, some new design tools, some of which may be a little surprising or something that users have not encountered before. But that's why we spent a lot of time to fill our website and the application itself with a lot of educational material like videos, tutorials, step-by-step design examples, and video hints everywhere where you can get an instant reminder of what one thing does or the other and how it works. So we hope that this will help users quickly get up to date and up to speed with the application. And I have a very quick 4-minute video that I would like to go through simply for brevity to just give an overview of what Phi working in Phi looks like. And then I will switch into a short live demo. So let's see if this is going to work. Full screen. Okay. So as you see here, the working with Phi is this type of very fluid, direct interaction experience where you move your things around and the surfaces directly, interactively update for you. You can add the smoothness and other features wherever you want. You can pull and push things around and give new dimensions. You can produce shapes with very few mouse moves and also switch into a multi-body environment. Here we have a bridge operation that connects these two completely freeform elements, and then you can smoothen them into the shape that you want, and things like that. So as I said, it's a completely integrated application, so you'll find it in a tab within your document when you start a new design. And you can get started either with one of the primitive objects that we provide for you, or you can import something that you've been working on in Onshape, in a Part Studio, and bring it into Phi, or you can continue from something you have left behind and saved. So for a very simple example, I'm just loading a cube here, and the simplest interaction is just to grab and pull an edge or a vertex, as you see, and the surfaces will immediately deform. There's a bunch of viewing options that I will present in a moment. You have many features. You can give very different appearances, work with materials and colors, You can give backgrounds as you wish to make the environment where you work more pleasant and as you like it. And as I said, you can save your work within a tab in your Onshape document. So everything is concentrated and nicely located within your Onshape document. Or if you want, you can export your work with a simple click to a new Part Studio in Onshape. So what you see here is exactly the design we had in Phi, translated into an Onshape Part Studio. You can add features to it like fillets, as you saw, or holes, or anything else you want. And if you update your work in Phi, this will automatically refresh in Onshape, and it will keep all the downstream features you added, like the fillets you saw here. So it's a very seamless interaction. On the top of the screen, we have all of the tools that are available for your design. I won't go through everything, but just to give you an example, we have a pop-out, which is like an extrude, and directly you can turn this into a move and a rotation that you see there. You can do freeform or very precise operations, give dimensions, for example, here, which can be applied to the entire body that you're working with if you want. Or you can select just a part of your body and rescale it. And in this case, the rest of it did not change, only where necessary to accommodate the scaling. You can add vertices with various operations that can make it quick and easy. And you can also add edges between the vertices. And any edge you add, like you saw there, or even by directly drawing it on a face with your mouse, as you see here. So this new edge is completely valid and available for you to use in your design. So here we popped out a new surface. And you can also eliminate volumes, delete parts of your body, of course. Or as I mentioned, you can make copies. So we switched into a two-body environment, which we then quickly reconnected with a bridge into one. There's operations for giving specific shapes, like the circle that you saw there, or more advanced ones, like the carve operation that you see here, where you effectively slice through your volume and only keep part of it. Smoothness is handled by Phi, allowing the user to specify where they want to have smooth or sharp edges, as you see here. You can also control the amount of smoothness and the strength of the operation, so how much the edges will change to give you the smoothness you require. And there's also two versions of symmetries. So a global mirror command that you apply to the entire body, or a localized symmetry that you can only apply to whatever edges you want. So part of your body becomes symmetric and the rest not. You can load reference sketches or even entire reference models that you can use to guide your design work, like here, where we select one face of this reference model and snap it into a Phi surface. So I know that this was very quick. I'm just wary of everyone's time. So let me move to the next slide if I can. Okay, so now I will switch into Onshape, and in fact in a Phi tab that you can see here. So this is Phi running within Onshape. This is my Onshape environment, and this is my Phi application tab here. There's plenty of viewing options. For example, I can hide my vertices. I can go into a hidden edge mode or hide the edges completely, and even hide the surfaces just to examine my edge network. I can switch from different viewpoints, or I can even save some viewpoints to come back to them. There's a set of coordinate planes that I can use to either orient my object or for some other operations. We can add a shadow plane, as you see here, which is useful sometimes when you want to have a better understanding of the 3D nature of your object. There is a grid for snapping. You can display the coordinates of all of your vertices or the moving parts of your object, etc. So you have, this is just to say you have many options for visualizing your work. So now, as an example, let's assume that I have this simple steaming iron here, and I'd like to make a change to it so as to give a better grip to the user so their fingers don't slip so much. So one way of doing this would be to select these two edges here, and they come yellow. Then with a very simple operation, I can add a couple of vertices on each one of them. There you go. And then I can select, for example, every second vertex here. And just by pulling on any one of these vertices, the rest of them will follow, as you see. and the faces will deform to accommodate this change. And so just with this very simple move, I was able to to edit this model as you see here. I think that the screen sharing is making my display very slow. So let me give another example of things you can do with Phi quickly. Let's assume that I wanted to add a different feature on the rear side of this iron here. So I will try to zoom here. And for example, make there you go. I was having some display issues, but now it's back to fast again. Okay. So I will zoom here at the back side of this iron. Let's assume that I wanted to add a hole here, an indentation, let's say, in the surface to allow for a cable to go through that. So I will use a simple carve operation. I don't need to be precise at all. I just trace a curve over the object. And now Phi is adding these two curves on the surfaces. It's very easy for me to adjust them by asking them to become okay, let me try this again. It's slowed down once more. So, okay, I select these two edges and I ask them to become a pair of circular arcs together. And I can do the same on the inner side. Okay, I'll be a little patient here. All right. And then, for instance, I can remove these two edges that define this shape here. And I'm left with a hanging vertex that I can easily get rid of. And then I can turn this into a linear edge, for example, or I can even just give it a slight curvature by pushing it with a shift key pressed, which makes it move perpendicular to the faces. Or if I'm not satisfied with this shape, for example, I can select it again and bring up the move command with a simple key press. Let me try this again. Unfortunately, the sharing is making it slow. Okay. Okay, that's the move manipulator, and I can then resize it as I want, as you see here, make it grow larger. Anyway, and these are the kinds of operations that you can do with Phi. Very direct interactions with your model and a very interactive update of the surfaces as you work. And now if I'm happy with this design, I can just hit this single button, give it a file name, and I click send to Onshape. And so this will initiate a translation of my work into a format that will be received by Onshape, and then it will be turned into a new part studio for me. I'll switch to this tab here. This is my part studio that Onshape generated for me. And there it is. So, and by the way, as I mentioned earlier, if you add some additional features onto this design, and then you go back to Phi to do some more edits to your work, they will be updated into Onshape again, seamlessly for you. I will not do this now because I see that the system is kind of slow and I don't want to waste too much time. So this was a very quick live demo, but I would like to also move ahead. And we have asked some of our users who have been kind enough to share some of their work with us, to quickly present what they have been using Phi for and their experience with it, because I think that this would be very interesting. So we have 4 designs that we would like to present. And first, I would like to invite Mr. Luca Loretti from the company Parametric Design in Italy, who has used Phi to design this freeform handle that you see here. So I will let Luca take over. Hello, I think you're muted, Luca.
Oh, okay. Hi, everybody. I'm sorry, I don't unmute my microphone. Everybody, thank you very much, Stefano, for the introducing. I'm Luca Reti from Parametric Design, and I am the technical specialist and account manager in Parametric Design for Onshape. I just will introduce a bit my company. Parametric Design was born in 2001 as an Italian PTC partner. Then in 2018, we decided to become also ANSYS partner that give us the opportunity to work in the simulation world. I am also a technical specialist about this. I am on ANSYS electrical business unit, in particular electromagnetic simulation at high and low frequencies. From 2 years, we are also Onshape partner, and I'm in love with this world. It's very, very cool, and really I like it very much. This year, we bought also the possibility to resell K-Shot, that is also inside the Onshape App Store. As you can see, we are also in Switzerland from 2008. We work in different markets like transportation. We work with Piaggio and Beta Motor, for example, or with Tiffany Mobile Design for design like the design market. We work also in the industrial market with customers as Schindler and Kone in the elevator marketplace. These are also only some examples. We have also a strong relationship with the Italian Institute of Technology at Genoa and the University Politecnico in Milan. Our company is strongly technical oriented. We are 18 technical specialists divided in different business from the 37 users that we are in total. Well, I think I can talk enough about me and my company. And so it's time to show you my work and incredible power that I think that give us the Onshape and see when they work together. Well, I just have a video about my work. And here we are in the free workspace. And first of all, I have to add a primitive object. For this project, I need a cylinder with the hole length 140 millimeters. As you can see, the model appears in our workspace, and now I have to set the right dimension for the two circles. We select the smaller one with the shortcut Shift plus left click, and with the exact circle feature, set the radius parameters as 12.5. In the same way, we set also the radius of the bigger one at 25 millimeters. Now I have only to repeat this operation on the other side. So the smaller one at 12.5 and the bigger one at 25. Now I want to insert some vertex on the lateral edge in order to set the distance between the peaks and valleys of our angle. So first, thanks to the shortcut Shift plus V button, I insert the vertex equally spaced, and after with the D button, the set distance window appears with which I can impose the distance from the central vertex that have to be fixed and the selected one. I do this operation for all the vertex that I insert before. So this is the last one. And now I have to create the peaks, first of all. So to create the peaks, I select the external and the central vertex. And with the move command, the shortcut Shift plus M, I move them along the right direction by 5 millimeters. Instead, for the valley, I move the second and fourth by -5 millimeters. As you can see, I obtain the classical harmonic handle shape. I would give to my model a rounder shape, and to do it, extrude the two inner circles by 10 millimeters, and after selecting each time a lateral edge and the two adjacent edges, I can use the smooth command in order to get to my handle a fatter shape that can be more comfortable for the final user. one of the cylinder has to be flat, so one of the face, the base cylinder base face of the cylinder has to be flat. So I move back the previous extrusion, and with the flattened common face, I flatten the face. Now I complete my work on C, and I have to go to Onshape to finish the handle. So I use the command that Stefano showed before, and as you can see, I am on Onshape now. Now I want to create the rubber and this one in the upper side of the handle. So create the plane, sketch on a plane a rectangle with this dimension, and extrude it as a surface. Then I use the surface and the plane that I created before to create the rubber one. Thanks to the Onshape multi-body feature, I can create and edit more than one body in my Part Studio and use the Boolean operation between them. In this case, I will use the union one. So as you can see, I split my handle, and now I use the Boolean operation. As you see, I rename the model in order to easily recognize them, and also I change the rubber appearance to give a better visualization. We have only to add the last things, the fillet chamfer to the edge. So first I add the fillet to handle, and after the chamfer, and now I have only to add the chamfer to the rubber one. I think that this linkage between C and Shape is really powerful and robust, and the combination of the two tools give us an incredible instrument to model easy anything we can imagine. So this is my presentation, and thank you very much, Stefano, for inviting me here, and thanks to the user of C.
Thank you very much, Luca. That was great. And I would like now to invite Laurent to also share his work with this vintage toy car design.
Okay, I hope you can see my screen now. And hi from France to everyone.
Yes.
I'm just going to start very briefly to present myself. So I studied as a mechanical engineer, working on Pro Engineer more than 20 years ago. And then I switched to teaching, and I'm a teacher, a STEM teacher, so science, technology, engineering, and math teacher in the French public system for more than 20 years now. And I also worked at a university level in Basel, in Switzerland, and Mulhouse in France. And for 3 years now, I also started my own STEM consulting company called Techademics, where I'm just designing curriculum for schools or STEM companies. And what maybe makes my path a little bit original is that I'm working with students or kids between 7 years old to 23 years old. So kids that we can call junior STEM kids, so starting at 7 to master's degree students at university. And what they have in common is that I'm working with Onshape with them 7 to 33. So what I'm doing here and what I wanted to show you today is a little bit of parametric design, you know, using Onshape and organic shapes. So on this slide, you can see 2 projects I had the privilege to do with my kids. So on the left side, you have, let's say, a classical robot. So it's powered by a microcontroller board. You can see at the bottom using Python. You have 2 geared motors inside and all the electronics inside. So that's pure parametric design using Onshape. So just for the little story, here's the result. This little robot that could just fit in your hand was designed fully online during the first French COVID lockdown. So that's, of course, as Neil always already said, that's one of the biggest interests of Onshape, is that you can just collaborate with your kids, even if you are not in the same classroom. But I wanted just to upgrade my robotics and my STEM subjects, and using Phi. So what I had in mind, because that's my motto since I'm working as a teacher, is that playing and play is the best and maybe the only way to learn in an effective way. When your kids have fun designing something, or even play or learn with something, then as a teacher, you are just hitting the home run. So I got a present for a couple months ago, and that was such a car made by a company called Play Forever from the UK. And I just fell in love with the curvy shapes, the organic shapes of those cars. And my goal was just, okay, can I just add maybe these kind of shapes to my robotics projects? And of course, as Neil also said, Onshape is offering great surfacing tools. So that's what I'm using with my older students. But what if I want to create shapes like this with small kids, with CAD beginners? And here, that's what, to sum up what I had in mind, was just to create organic and curvy shapes to my projects, but of course, by adding mechanical design inside. So what I did was using Phi for the organic and the curvy shapes of this robotic car here, vintage robotic car, and then switch to Onshape to create the more traditional mechanical design inside. And what's really, really great about the combination of the two tools is that it's a two-way process. As Stefanos already said, is that you start in Phi to creating your curves and your organic shapes, and then one button away, you are just one button away from Onshape, where you can add the mechanical design, and then go back to Phi to make some changes, and it automatically changes your Onshape model. And so here is just the result. So you have the curvy outside, the aesthetic, and then inside you have all the technical parts like the microcontroller board, the gear motors, and all the sensors. So we teamed up with Phi and Stefanos to create this tutorial. You have the link here. It's already also on the Phi website. So I just wanted to show you something, and that's the start. So imagine you have a kid, maybe 8, 9, or 10 years old. He's not, or she is not, starting with an empty document. He is able, or she's able, just to put on the background a picture of the toy he wants to mimic. And then the other way, on the other side, you are not starting with an empty document. You are starting here with a cube. And the goal and the game, I would say the game, is just to make your cube fit the picture you found on the internet, and to create the toy you just want to 3D print later. So you can find the entire process here on the Phi website. So just to show you maybe the result here. So that's the car. So it's a toy, but you can, of course, open it, and you have all the electronics and all the mechanics inside. And here you can just see a glimpse of the process. So using Phi, I was able just to design the outside of my car. And as I said, you are one button away, this one, to send your organic shapes to Onshape, where you can just start here, add all the mechanical shapes or the mechanics inside. So you can see the results here with nice wood wheels inside with all the electronics, and then you can just start producing whatever you want, your exploded view, your technical drawings, and whatsoever. So just to conclude here, on the left side, you have the organic and curvy shapes. Even a kid starting at 8, 9, or 10 is able to produce, and that's the game changer. And you have the mechanical design using Onshape on the right side. So if you just want to also produce a tiny and nice looking car, you can just find the entire tutorial on FAI website. Okay, so maybe back to you, Stefanos.
Thank you very much, Laurent, for this. That was great. I will quickly zoom through two more examples. One of them, I'll be presenting both of these myself because this was provided to us by a company who preferred to remain nameless because they work in a very competitive environment, and so they just didn't want to disclose exactly what they're doing and who they are. So that's one. And if I manage to go to the next slide. Okay, this is our last product. Again, I will quickly present this for a different reason. Now, this was developed by a student, an educational user of ours, and unfortunately, he's simply at school taking exams right now, so he excused himself and just sent us a short video, and I will be speaking over it. So let me start this.
Hi, I'm Pavlos. I'm a 12th grade student, and I'm currently making a stovetop coffee maker using Onshape and its FAI extension.
So Pavlos designed everything in Onshape, as you see here. He used a lot of the tools that Onshape provides, and he was very enthusiastic about the process. But he decided to design the spout and the handle in FAI, and we'll quickly go through this process. So for the spout, he started by bringing in as a reference the Onshape container that he created here. And then he selected these two faces that you see, and he converted them into 5 faces. He then stitched them together using the stitch command to create one single V-shaped face. And then he popped it out to create a volume. And then he selected this middle edge and simply pulled it up all the way, and then rotated and pulled it forward to give the general shape of the spout. He got rid of some extra edges that were no longer needed, turned everything into straight lines, and then selected this middle edge and pulled it to give it a curvature, switched into hidden edge mode, as you see here, to do the same for the other edge. And then simply by adding 4 vertices, selecting them and moving them all together, he gave this curved shape to the spout. Then he brought back in the reference model to make sure that everything fits. And then he sent the mouthpiece, the spout over to Onshape, where it appears, as we said again and again, as a new part studio, as a new part actually. He integrated this with the container and with a simple Boolean operation made it one single part, and there it is. And now for the handle, that's a slightly more complicated design. So he started with a simple cylinder, which he placed and rotated and scaled. And then with a series of pulls and pushes and pop-outs, as you see, he was able to trace the contour of the handle at the lower part. And then he placed the edges as he wanted and added a smoothness to give it the shape that was required. The gray part that you see is fixed. So what we usually do is we fix parts of our design to make sure we don't ruin anything there as we move on with other parts. So he completed this process moving upwards bit by bit until he reached the point where the handle is connected with the actual coffee maker container. So he examined the connection and he realized that he had to move from a freeform to a more rectilinear ending over there, which he easily did in Phi by adding some straight edges. And then he again brought in the reference model just to make sure that everything lines up correctly, and then sent his work from Phi over to Onshape. And there it is in a new Onshape Part Studio. Again, he put it together with the container. As you see here, everything fits. He did some Boolean operations to remove the additional volume from the Phi part, and also he removed those cylinders to drill the holes. And the part now is perfectly ready to be assembled with the rest of the coffee maker, and this is the end product. So I think this is a good example of how you can combine working in Phi with working in Onshape and take advantage of the power of both tools. So this really concludes our presentation. We tried to go through a lot of material and give you the perspective not only of our own work but also of our users, because in the end that's what really matters. And thank you very much for participating, and Onshape and Neil and Conrado for organizing this. And if there are any questions, I don't know how much time we have.
Yes, we've got about 7 minutes to answer any questions. So they've got quite a few questions in here, Stefanos. So I'll try to pick out a few within the time available. Question here: do you have any examples of complex surfaces, especially blend surfaces that have wall thickness and fillets added? I'm guessing something much more complex.
Right. Examples to show right now, no. There are various examples on our website, and also if you have any specific designs in mind, we'd be more than happy to have a look and discuss them with you. But just to give a broad answer, in Phi, you can create complex surfaces as by starting with a simple surface and then adding more edges. So what you do is you split your surface in parts, and then every part has its own independent freedom, so you can define the shapes that you want. Regarding, I think you mentioned thickening or other operations on the surfaces. Currently, we rely on Onshape's capabilities for some of these operations, like Boolean operations you cannot currently do in Phi, or filleting. But we have lots of plans for providing some of these facilities in the coming months. For a more specific answer, we'd be very, very happy to discuss on anything you have in mind.
Okay, another question then. Can you add dimensions to your model in Phi, like for example, the total length of the model or for radii, things like that?
Yes. Let me switch here. So Phi has a lot of capabilities for adding dimensions. I think just to give you an example, you can, for example, select these two vertices here and directly bring up a modal interface for setting distances. And you can also specify whether you want the entire model or the object that is attached to these two elements to be redimensioned or not. You have a scaling tool, which is very advanced. Again, everything slows down. So let me very quickly. We're able to see, there you go. Okay, so we have a scale tool that allows you to dimension everything in terms of percentages, but also if you select specific elements of your design, you can also scale it with respect to the distance between these elements. And so you have these tools that are available to you, and you can also directly place coordinates of your objects. Now, one thing that I should make clear is that these dimensions currently they only reside within the phi world. So once you export this over to Onshape, for example, you export the geometry and the model that you have created, but at that point you have to rely on Onshape's capabilities for redimensioning, rescaling, and everything which are there. So you independently dimension within phi, and then you export it into Onshape. You won't see the phi dimensions within Onshape as mates, for example.
Okay, thank you. I'm going to try and combine 3 questions into one here from 3 different people. But the question really is, with each edit that you do inside phi, are they traceable? Can you undo them? Can you create versions? Is it listed in the Onshape document history?
Right. The answer is simply currently no. We have our own edit history, and you can undo, redo, etc. But this information at this point is not something that we share with Onshape. What you can do, however, is at various steps of your design process, you can export by simply clicking on the Send to Onshape button. And by the way, there's no delay for you at that point. I mean, if I click on Send to Onshape, as this process is happening, I can continue my design work within phi. So if you do this, then every time you export, this is added as a trace within the Onshape history. So at that point, you would be able to take advantage of the history capabilities of Onshape. Phi in itself only gives you currently an undo, redo stack.
Perfect, thank you. Another question, are designs created using phi usable with simulation add-ons available in the Onshape App Store?
Any design created in phi, once it's exported to Onshape, it's a completely valid Part Studio. Actually, the export goes through the step format, which is also a file that you can retrieve from Onshape and use it in any way you want. So there are no limitations at that point. I have not personally used simulation software to give a more specific answer, but given that it's a completely well-defined regular BREP representation, I don't expect any problems.
Probably the last question now. So everything we've looked at so far is in a part studio. Can you work on an assembly? Can you open more than one part at the same time and work on those?
Yeah, sure. I mean, so everything you design within phi, if you have a multi-body model in phi and you export it, this will result in many parts in Onshape. And you can then use these parts in an Onshape assembly. Phi in itself, within its own interface, does not have an assembly capability. You can have many parts, you can snap them together, you can join them by merging them, but you don't have more advanced assembly capabilities. But Onshape offers all of this for you.
Okay, perfect. Well, we're up to the hour. So there's a lot of content included in there, some great answers to some great questions. So I'd like to thank Stefanos and all his guests for showing us phi, and also thank you as well for taking the time to attend today's webinar. So thanks very much and have a great day.
Thank you, everyone.
Thank you.
Thank you, Neil.